Hey everybody, welcome back. And if you're just checking out the channel for the first time, welcome, glad to have you. So in this video series, I'm working on building a 3D city simulator in JavaScript, similar to one of the old school SimCity games. In the previous two videos, I walked through how to set up the 3D scene and the camera, so I highly recommend checking those out if you haven't yet. In this video, we're focusing on building the simulation model for our city. And on the screen right now, you can see the final product that we'll end up with at the end of the video. So what you're looking at is each tile on our game map has a chance of developing into a building. And those buildings can grow to be 2 or 3 blocks tall. This is very simple, but we're going to build on this foundation in future videos and start adding some more complex logic into how these buildings develop over time. So let's get started. All right, so let's start off by defining the data model for our city. I'm going to create a new file under our source directory called city.js. So in this file, let's start by creating a function called createCity. So we want to be able to create cities of varying sizes, so let's add an argument called size. So our city is going to be a 2D grid, and the size corresponds to the length of one side of that grid. Let's create an array that will store the data for our city model. This will be a 2-dimensional array. Let's create a method called initialize where we're going to initialize that 2D array. So let's loop over all of the X and Y coordinates on our city grid. So how we're going to do this is we're going to build this 2D array column by column. I'm going to define a new array here called column. And then for each pair of X and Y coordinates, I need to create an object that represents the data at that location. I think of each location on my grid as a tile, so I'm going to give this the name tile. And let's create an object that just contains the X and Y coordinates at that location. So I'm going to add that to my column. And once I'm done building a column, then I'm going to add that to my data array. All right, perfect. So last thing we need to do is return our city object. So to start with, our city will have 2 properties, the size of the city and this 2D data array. And then before I forget, we need to make sure we call our initialize method. So to make sure that our data array is initialized before we return that. So right now, all we have is a 2D array of data. And each element in this array contains an object, and that object contains the X and Y coordinates at that location. So that's not a whole lot, but we can use that to render out a very basic map of our city right now. Let's jump over to our scene, and let's add a new method here called initialize. And what we want to do is we want to pass in our city data model to the scene and then have this scene create 3D models from that data model. So let's pass in a city as an argument here. And similar to what we did before, we're going to loop over every tile in that city. What I want to do here is for each tile in the city, I want to load the mesh corresponding to that tile. So a mesh is synonymous for a 3D object. I might be using them interchangeably. What we need to do is to create an additional 2D array that's going to store those meshes. So I'm going to define that up here. And we're going to build out that 2D array in a similar fashion to what we did for our city, column by column. Let's go ahead and just add that column right down here. And right here is the tricky bit. So I'm just going to add some comments and lay out our process. We need to load the mesh slash 3D object corresponding to the tile at the X and Y coordinates. Need to add that mesh to the scene. And then we need to add that mesh to the meshes array. So the reason we store the data in a separate array here is if a tile updates its state, then we can go and update the mesh corresponding to that tile. So for these first 2 steps, we've already kind of done this before with the basic cube we have in our scene. So I'm going to move this code down here. And one additional step we'll need to do is to set the position of that mesh. And that's going to live at the X and Y coordinates for that tile. And note that while we're representing our city model using X and Y coordinates, because it's just a 2D representation, our city is rendered in a 3D world. So the horizontal plane is the X and Z plane in that world, and the Y axis is up and down. It's a little bit confusing, but we have to map the Y coordinate in our city model to the Z coordinate in our 3D scene. So after we set the position, we add the mesh to the scene. And then finally, we add that mesh to the column. So we may be calling this multiple times. So to be safe, at the top of this, let's make sure to clear any objects in our scene. And then we're also going to need to reset our meshes array here. Okay, so the last thing that we need to do is to return this initialize method so we can access that from our index file. All right, so we've set up our city model here and we've created a method on our scene so we can import that city model and render that. So the last thing that we need to do is go into our index.html file and we need to create a city model and then initialize our scene with that. So let me import create city here. And then I'm actually going to pull this out and do a separate constant. We also need to create our city. Give that a size of 8. And then, of course, initializing our scene with our city model. All right, so let's go to the browser and see what we got. A much larger part of the screen is now red. So if I rotate, you can see that what looks to be an 8x8 grid of blocks. So it's actually rendering every tile in our city now instead of that one cube. So I think my camera is a bit wonky because I'm not setting the initial elevation for that. So let's actually change our camera radius min and max to 10 and 12. Then right when we initialize the camera, the initial radius will be the middle point between our min and our max. And let's set our default elevation to 45 degrees. And I think this needs to be 135, so we're looking at the city. So if we go back here, all right, there we go. So the everything's in view now, and our camera is set to a proper elevation angle. All right, so this looks great, but one issue we have is we still don't have any lighting. I think we need to address that before we do anything further. So going back to the code, going into our scene, let's create a new method below initialize. And call that setup lights. Here we need to define an array called lights. So let's add 4 different lights to our lights array. The first one we'll add is an ambient light. We'll give that a color of white and an intensity of 0.2. So this is kind of the base lighting in our scene. Ambient lights don't have any direction, so everything is equally lit. This is the only light that we have right now in our scene, and this is why everything looks flat. So in addition to our ambient light, let's add 3 directional lights. Make these white as well. Give them a slightly higher intensity. And now I need to set the direction for each of my directional lights. If we mouse over that, we can see that we set the direction via the position property. So if I set the Y component of the position to 1, that will cause the light to shine from top down. So let's set the position or direction for each of these. We'll do a top-down light. And then for the other 2, we'll just pick some arbitrary directions. Give a 1 there and a 1 there. And we need to add these lights to our scene. And we can use the spread syntax to add all the lights simultaneously. So finally, we need to call our setup lights function. So the best place to do that is in initialize after we've cleared the scene. We'll throw it at the end here. So let's call setup lights. And if we go back to the browser, it looks like our lighting is still flat. And the reason for that is we're using a basic material for our meshes. So that's being defined right here on this line. You can see we're using mesh basic material. So this is a material without lighting. We need to pick one that does support lighting. I'm going to pick Lambert for that and stick with, actually, let's change this to green since we want it to look like grass. Maybe darken it slightly so it's not so lime green. Going back to our scene. There, it looks like we finally have lighting. You can see that the edges are a different shade of green than the top. So this is nice because we don't have to look at this flat 3D shaded object anymore. We can actually see the geometry. So perfect, that works exactly like we want it to. And this looks like a really good grassy base for our city. So our next order of business is to add some buildings to our city. Let's go back to our city.js file. And we're going to expand upon our tile definition here. I'm going to add a new property called building. Give that a value of undefined to start with. And then just for testing, I'm going to randomly generate buildings on different tiles. So I'll do if math.random is greater than, let's say, 0.7, and tile.building equals building. So this is just a label for the type of building to render there. Obviously right now we only just have our test building, our placeholder building that we're going to render. But eventually this could represent different residential buildings, commercial buildings, hospitals, schools, things like that. But for now, this will allow us to render a placeholder. Let's go back to our scene. So this code here is currently used to add the geometry for our grass to the scene. So this is our grass geometry. So we need to copy and paste this. And this will be our building geometry. We'll need to give these different names. And we'll be refactoring all of this code later, so it won't be quite so messy. But it'll suit our purposes for now. The default box that comes with Three.js, the origin is at the center of that box. So that means that if we set the Y position to 0, then half that box is going to be above the XZ plane, and the other half of that box will be below the XZ plane. So I want to render the grass below that plane. So I'll give this Y value of minus 0.5, and then we'll render our building above that. So that'll render our buildings above the grass. And let's give our buildings a generic gray color. So the last thing we need to do is to check if there's actually a building at that location. So let's get our tile object. And then if tile.building equal to building, then we will add the geometry for that building at that location. So let's go look at the browser. And there you can see that we're rendering buildings on top of our grass. This isn't very interesting right now. So I think what we need to do is to add in some logic so that our buildings can change and evolve over time. So like I showed in the intro part of this video, our buildings can grow to be 2 or 3 blocks tall over time. Let's go back to our code. So the next thing we need to do is to add an update loop to our game. So every second the update will run, it'll update the model of our city, and then we'll update the view to reflect the new changes in the city. So in order to manage all of that, I'd like to create a new object which does all the management of the update cycle. So I've already gone ahead and created a file called game.js. So go ahead and do that now. So let's create a function in here called create game. The first thing I'd like to do is to take all the code we have in our index.html file and move that into our game. So the game is going to handle all the setup of the scene, the setup of our model, hooking up all of the mouse events, and eventually our update cycle. Let's go ahead and just copy this code and paste it in here. And I'm quickly going to just update all of this code so it works in this context. Then let's go back to our index.html file. Let's import create game instead. Delete this import. And then when our window loads, we'll call create game. Let's go to our browser. And there, our city is loading just like it was before. So perfect. We've migrated all of our game setup code into our new game function. The next thing we need to do is create a game object. So this object is going to have our update method in it. This is going to update our city model. And then finally, it's going to update the scene with the new city data. So we haven't implemented these methods yet. So let's go do that. So we'll go into city. We'll create a new function called update. And here we want to iterate through each tile and update the tiles. So I'm going to copy our for loop here. So I want to update each tile. Now we need to go one level deeper and add an update statement for our tiles. So we'll add an update method to our tile object. So in our update method for our tile, we'll just add a log statement here, updating tile X, Y. So we should see this update for each tile. So let's export our update function from our city. So we can call that from our game. And we'll just comment out the scene one right now. We haven't implemented that one yet. So we want our city to update, let's say once every second. We can change the speed later, but let's start with that for now. So right below here, let's call set interval. This will create kind of a new timer that updates on a regular interval. And we'll call game.update. And then we'll run this every 1000 milliseconds. So when we create our game, it'll automatically kick off this timer and it'll call our update method on our game every second. So we need to make sure that we return our game. And that way we can access it later on in our index.html file. Let's change this slightly. Now that we're returning an object, we'll store the reference to the game on our window. So we create buttons later to pause our game, to start a new game. So that's when we'll need that reference to the game object. So we should be able to go back to the browser now and see our update loop running. And it's a bit hard to see because there's so many console log statements running, but you can see that it's printing out the updating tile XY log statement for every single tile every second. Let's make that a bit more readable. Let's go back to the city and I'm going to move that log statement to the update method for our city instead. It's called updating city. And if you go back to our browser, we can see if you watch the counter right here, every second this is incrementing by 1. So we have our basic update loop set up. So now we need to actually do something in that update loop. So let's have our buildings grow over time. So it'll start as an undeveloped piece of land. Then our buildings can grow to 1, 2, or 3 blocks tall. So in the update statement for our tile, let's build out that logic. So I'm going to just get a random number here. This is a floating point between 0 and 1. So let's say that there's a 1% chance that our tile will evolve to the next step. So if our building is undefined and we want to develop it to the first stage, we'll just give this a tag of building-1. If our building is in the building-1 stage, then we'll move it to building-2. And lastly, if we have a 2-level building, then we'll develop it to level 3. So each of these has a 1% chance of happening, and we're moving from one step to the next. So this is a very simple state machine for our tiles. Eventually, this will be much more complex logic, but for now, this will give us kind of a city just randomly growing over time. And lastly, we need to remove this old bit of logic that we added that would just place random buildings. So we'll start off with a completely undeveloped city. So we need our building to grow over time as it moves between stages. So let's go into our scene file. And let's modify this section of code slightly so we can account for different building heights. So now we need to see if this starts with building. And then the height of our building, if we go back and look at this, we can see that the height is stored in the last character of this string. So we can just do tile.building.slice -1, and this will grab the last character of that string. And let's convert that to a number. So let's update our building geometry. So this will be the height. And let's set the position to height divided by 2. And let's add a quick null check here. So currently the code that generates our building geometry is in our initialize function. Our city doesn't have any buildings when we start, so we need to move this to an update function on the scene. Let's add that function here. And remember that we need to pass in the city data. Let's copy this whole loop here and just remove the parts we don't need. So we're not going to regenerate the grass geometry once it's in the scene. You can also remove these lines here since they're no longer needed. And let's make sure to go back up to our initialize method and remove this bit of code here that's now in our update method. So the next thing that we need to do is when we update the building geometry, we need to remove the old geometry in the scene. And that's what we set this meshes array up for. So currently we're storing all of our grass in that. So we need another one of these arrays for our buildings. Let's create a new one here. And then let's do a rename on this one and call this terrain. So we'll start with an empty buildings array when we initialize. And we can just go down here and push an empty column onto our array. So we do that like this. So this is a bit of a tricky syntax here, but this will create a column of undefined values. And the number of elements in that column will be city.size. So we should end up with, in this case, an 8x8 array of undefined values. Now in our update method, before we add our building mesh to the scene, we need to remove the old one. So if a building exists at this location, then we need to remove that from the scene. And then finally, we add the new mesh to the scene. Then we'll update our buildings array to store the new mesh. And I know some of you might be worried about the fact that we're creating a new piece of geometry and a new material for every single tile. Yes, that is really inefficient. So we're going to refactor all of this code later to make sure that we only create the geometry and materials that we need and then reuse those. I believe we have everything set for our update method. So let's make sure we export this or include it in our scene object. There we go. And then let's go into our game and make sure that this line is uncommented. So let's go to the browser and see what we got. Everything should be working by now. So it looks like buildings are immediately going to stage 3. And I think I know why that is. go back to our city and did something kind of dumb here. So basically, if it's building 1, then it's going to hit the rest of these if statements. So these should be else ifs. And that should fix that. And also, let's make our city a little bigger. Let's do size 16. Let's go back to the browser now. Everything should be working. Do a quick refresh to get a new city. And there, it looks like our city is now developing over time. We can see some of these buildings have already moved into the second stage. They're 2 units tall. So I think this is about as much as I'm going to pack into this video and starting to get kind of long. In the future, I'm going to try and make these videos a bit shorter because it takes me so long to produce these longer ones. And in the next few videos, I think we'll work on, for one, we need to fix the fact that we're creating new geometry and materials every update cycle. That's probably going to cause the browser to crash at some point. And let's also add some user interaction in, so we can select our tiles, we can place different zones on different tiles, and then that'll eventually move into creating some more complex logic for our city. So we can start adding roads in, make sure zones only develop when they're next to roads, have some balance between residential, commercial, and industrial zones. So these are all interesting topics that we're going to explore in the next set of videos. So thank you so much for tuning in. I hope you stay along for the ride as we work on this. I'm having a lot of fun with it. I hope you are too. Thanks for watching. Take care.